Hey, class. Okay, so, so it looks like uh, when I was analyzing the data in SPSS, that didn't quite come through in the recording. So I'm going to try it again here, show you how to run a correlation and get the regression line in SPSS. So let me try that again. Share. Sorry, bear with me. Okay. So if you pull up the data file associated with this, it's called HSB2. This is some data from the high school and beyond survey. It's a national survey from the National Institute for Educational Statistics. And so it just has it's just a sampling of some of the data in there. So it has information on the gender of the student. So 1 if the student is female and 0 if they're male. There's a race variable, an indicator of their SES, the type of school they attend, whether it's public or private. And then they have different assessments. They have a reading assessment, writing, math, and I think social studies. So let's say we want to find out the correlation between reading scores and writing scores. We would go to Analyze, Correlate, Bivariate, and bring over the scores that we're interested in, reading and writing. And if you wanted to get the Spearman or the Kendall correlation, you just check these boxes as well. We click OK. The first table here is the Pearson correlation. So the correlation between reading scores and writing scores is around 0.6. So as reading scores increase, writing scores increase. Or you can say it the other way. As reading scores decrease, writing scores decrease. The next set of boxes, or of output rather, has our we're called non-parametric correlations. So that'd be our Spearman's Rho and Kendall-Tall coefficient would be in here. If you look at Spearman's Rho, it's very similar to our Pearson's R. It's still a correlation of about 0.6. It's positive, indicating that as we increase in reading scores, we increase in our writing scores. And we sort of get the same information from Kendall-Tall as well. You notice that the Kendall-Tall is weaker, and it tends to show weaker relationships than Spearman's Rho. You can read more about the differences between these in my extra correlation coefficient notes. I just kind of wanted to show you how you would run these in SPSS. To get the scatter plot, you would go to Graphs, Legacy Dialogues, Scatter Dot. We just want a simple scatter plot. We typically will graph our dependent variable, what variable we want to predict on our y-axis. Say we want to predict reading scores from our knowledge of our writing scores. We would graph reading on the y-axis and writing on the x-axis. We'd say OK. Then we would get this nice scatter plot. So you can kind of see in here, see a kind of upward trend to the data, right? As writing scores increase, reading scores tend to increase. So this would be the graph if we were trying to predict reading scores from our knowledge of writing scores. If we want to get the regression equation fit in here, we double click on the scatter plot and you click this fit line at total here. I think it defaults to linear. If not, you click the linear button here. And if it hasn't applied, you can push apply. If not, just close that. And we can just exit out of here. And then we have our equation here. So the slope coefficient here we would interpret as a 1 unit increase in writing scores corresponds to a 0.65 unit increase in reading scores. The constant here is 18.16, so this would be the predicted reading score when writing score is 0. I believe in the last example, I think I did it the other way. So if you did it, if we graphed them the opposite way, say we wanted to predict writing scores from reading scores. We put write on the y-axis, reading on the x-axis. Still see a positive relationship, but notice that the regression equation is different. Notice that the regression equation between these two are different. Notice the scatter plot looks slightly different. Still a positive relationship, but the R squares are still the same in both. See the R square here in the corner of the graph, or the corner of the scatter plots here. In this case, so we're using reading scores to predict writing scores. The constant means that this is the predicted writing score when reading score is 0. The slope is interpreted as a 1 unit increase in reading scores corresponds to a 0.55 unit increase in writing scores. Notice that the regression equation is different because they have different meanings on which variable we're trying to predict, right? You know, we want to know the relationship in writing and reading scores. Then a 1 unit increase in writing corresponds to a 0.65 unit increase in reading scores, where a 1 unit increase in reading scores corresponds to a 0.55 unit increase in writing scores. I believe, so it matters how you graph your data here as to which regression line you're getting. This equation predicts reading, or this equation rather predicts writing scores from our knowledge of reading scores. This equation predicts reading scores from our knowledge of writing scores. The other way you can get a regression equation is analyze regression linear. Let's say writing is our dependent variable. We put it in with dependent. Reading is our independent variable. We can plot it in here. Our model summary gives us our correlation squared, or the coefficient of determination. There's a standard error of the estimate that we talked about. You can ignore this ANOVA table here, and your regression equation would be right here. So remember, a 1 unit increase in reading scores corresponds to a 0.55 unit increase in writing scores. So this was our slope, and then our constant here is also, you know, this is our regression constant, or where the line crosses the y-axis. It's also the point, so this would be the predicted writing score when reading score is 0. So that is just the quick rundown with the SPSS output. I hope it worked this time. I'm sorry for any confusion. Thanks. See y'all next module.